Okay, here's warm-up number 22. We've got a quadratic inequality here. Okay, so if you imagine that this was an equal sign, this would be a parabola. So this is going to look like a parabola, except this is telling me that we are going to have, instead of drawing it with a solid line, it's going to be dashed. So I need to keep that in mind. Okay, and then this part, since y is greater than, I'm going to be shading above the vertex. So already without just making a little sketch up here, my x, my a term, the coefficient of the x squared term is positive. So I know it's going to open upwards. I know it's going to be drawn with a dashed line. Okay, and the vertex would be down here. And since it says y is greater than, if you have it in y equals form, you can use that shortcut. Then I'm going to shade above the vertex. So it's going to look something like this. So really we just have to be able to graph the parabola accurately and use this model. Okay. All right, so since this this inequality is in standard form, I'm going to find the axis of symmetry first, and that's going to lead me to the vertex. Okay, so the axis of symmetry formula is x equals negative b over 2a. So the b here would be 2. So I've got the opposite of 2 over 2 times a. A is 1. That's the coefficient of the x squared. Then I'll simplify this. Okay, negative 2 over positive 2 would be negative 1. So the axis of symmetry is the line x equals negative 1. Okay, I'm just going to draw this very lightly. X equals negative 1 is going to go down something like this. Okay, so that means my vertex has to be somewhere on that because that's going to be the middle of the parabola. Okay, so then my vertex, I know what the x-coordinate of it's going to be. It's going to have to be negative 1. I just need to find the y that goes with it. So I'm going to just pretend that this is an equation, and I'll plug in negative 1 for x to find the y that will work with it in this equation. Okay, so plugged negative 1 into both those slots. Let's start simplifying now. Negative 1 squared is 1. 2 times negative 1 is negative 2. So let's see, that's going to give me negative 5 when I do the arithmetic there. So that's the y-coordinate. Okay, so now I can plot, my vertex is going to be negative 1, negative 5 right here. I know it's going to open upwards, okay? And you could find one thing, there's a couple of things here you could do. You could find the y-intercept would be pretty easy to find. Also, since the coefficient of the x squared term is 1, it's just going to follow the, if you know what the parent graph looks like for a parabola, it's going to go up 1 to the right 1, and up 1 to the left 1, and then it'll go up 4 to the right 2, up 4 to the left 2 from the vertex. Okay, so you could do it that way. You could also just find the y-intercept by plugging in 0 for x. And then both of these terms just drop out, right? They're both 0, so then my y-intercept is negative 4. Got that? And then I can reflect that over the axis of symmetry. Okay? So, you know, I could do the same thing. I could plug in 1 for x to figure out what y pair goes with it. But since I know this is going to follow the pattern of the parent graph, I know I went up 1 to the right 1, and I'm going to go up 4 to the right 2, up 4 to the left 2. You could also find the x-intercepts, although they're not going to be integers. They would be somewhere in between 1 and 2. Okay? But now I've got a pretty good idea of what this parabola looks like. I just got to remember I'm going to do it with a dashed line. Okay? And then I need to indicate all of the xy pairs that are going to work with this inequality. There's a whole lot of them. There's an infinite amount. They're all the ones that are in this region. So you can use the shortcut I talked about at the beginning. Or you could choose a test point. You could try out 0, 0. It will work with this inequality because it's in the shaded region. Any point that's not like 2, 0 would not work. Or, you know, negative 5, 0 or something like that. So the shaded side is the side that works with the inequality. Okay. All right, and then next up, I've got another quadratic inequality, but this one's different because there's no y-coordinate. So I'm not going to graph this on an xy grid because I don't have any y's. So you can graph this on a number line, and that's actually what I'm going to do. But first, I'm just going to pretend that this is an equation and solve it. So what I'd want to do, I'm going to leave that equal to 0. If I can factor, I'm just pretending it's an equation, I'm going to factor the left side of this. So I'm going to use a diamond problem. I'm taking the 2 up there, looking for 2 numbers to add to 2. Same 2 numbers multiply to negative 15. Okay, so if you think through that, not too many ways you can multiply to get negative 15 with integers. I think there's only 4 of them. There's all 4. Don't necessarily need to write those down, but only one of those pairs is going to add to positive 2. That's the negative 3 and positive 5. And that's going to, those 2 numbers show me how to factor this. So that's what goes in the back of these parentheses. Okay, so I've got this, okay? And now if I continue to solve this for x, either x minus 3 equals 0 or x plus 5 equals 0. I'm using the 0 product property here. So then I've got these 2 different x values. Now if this was just an equation that said solve, then I'm finished, but it's an inequality. These are going to be the dividing points, okay? So I'm going to sketch a number line. And the only 2 numbers that I'm going to put on my number line are these 2. And since negative 5 is less than negative 3, I want to put that on the left. And I'll put 3 on the right. Now, you could put in all the other ticks in between, but those are the really important places, okay? And this is telling me, since that's not underlined, I'm going to have an open dot. So I'm going to put an open dot above both of those values, okay? And so now I need to figure out, that's where my number line gets divided into the parts that are solutions and the parts that aren't. So maybe I've got solutions here and here and not in there, or it could be the reverse. So I'm really trying to figure out if I've got arrows going out either way from the negative 5 and negative 3, or if I've got a line segment connecting them. So to figure that out, I'm going to use some test points. So I'm going to pick a number in this region. I'm just going to pick the smallest integer, the most convenient integer I can. I'll use negative 6, and I'm going to test that out in the original inequality. And you could actually use the factored version if you wanted, but I'm using this one. But I do have the inequality symbol in there. Okay, negative 6 squared is 36. 2 times negative 6 is negative 12. Okay, and when you add this all up, or you do the subtraction here, I'm going to get 9 is greater than 0. That is true, okay? So that's telling me that this region on the left is a true part, so all of the points in that region should work. That's in the true zone, okay? Now I'm going to choose a number in the middle. I'm guessing it usually goes true, false, true. It usually alternates like that, but just to make sure, let's test it. I always like to use 0 as a test point. It's the easiest number to use unless it's one of your dividing points. So let's plug that into the original equation, or the original inequality, I should say. So those 2 drop out. All I've got is negative 15 is greater than 0. Well, no, it isn't. Negative 15 is not greater than 0. This region in the middle then is false. Okay, so again, I'm guessing this is going to be true over here, but just to make sure, let's pick a test point. I'll use positive 4. And again, plugging in this into the original inequality. So let's see, 4 squared is 16, 2 times 4 is 8. And that's going to give me 9. Again, 9 is greater than 0. Well, that's a true statement. So that means this is a true zone. And you could write, so I like to just write my solutions as number line graphs. But you could also write 2 different inequalities. You could say x is less than negative 5 and x is greater than 3. I guess, or x is greater than 3. And that's it for the warm-up today. All right, see you next time.